We're gonna look at polynomials. What is a polynomial? A polynomial is just an expression with more than two algebraic terms. What's the algebraic term? Maybe it's like a letter, variable, or like just a number, or a variable and a number. Okay, all right. Well, let's look at a couple examples real quick. Just small little examples. Actually, a polynomial can be two terms also. It's just anything that's more than that. This is like a linear polynomial. What? We'll think about that later. This is the second degree polynomial because its highest exponent is 2. And then maybe we have like something like this. That'd be a third degree polynomial because of the 3 there. Second degree means it's second degree. Just highest power of 3 means it's a third degree polynomial. Actually, when a polynomial has only 2 terms, like this, it's actually called a binomial. And then if it has only 1 term, it's called a monomial. Binomial. So, we're going to actually look at multiplying binomials. That's what we're going to look at first. So the first example here, we got to look at this, we got to look at this, we got to look at this, we got to think, okay, what we do, huh? What we do? If you don't know what to do, you look at your notes, because that's what these notes are for. You don't know what to do, you pay attention, listen, you watch. All right. Multiply the following binomials. That's an S there. Multiply these binomials. And some of you may know how to do this already. You use the FOIL method, where you multiply the first terms. So you multiply the first terms. Well, that would be x times x. We notice those are both the first terms. Those are the first term here and the first term there. So multiply the first terms. And that would be x times x. That's just x squared. Okay, that's fantastic. What is the O? Then you multiply the outside terms. What the heck are the outside terms? M and the D. There'll be the stuff on the outside. It would be the stuff on the outside. There'd be x and 4. Those are the outside terms. So what does that mean? Well, that means what is x times 4? That's just 4x. All right. And it's positive, right? We're multiplying positive times a positive is a positive. Okay, so we'll add those. The next part is the I. That means multiply the inside terms. What is that? That's negative 3 times the x there. Well, that's easy. Negative 3 times x, that's just negative 3x. Becomes minus as well. Okay, what's the last one? Last, that's what it is. You multiply the last terms. So what does that mean? That means negative 3, right? That's the last term. And 4, that's the last term in that other binomial. So negative 3 times 4, well, that's just negative 12, right? Whoops, I'm going to write it out like I've been doing it. Negative 3 times 4, that's negative 12. Ooh, what next? M and D, they're like terms there. We can combine like terms. We can combine like terms. We can. Look at that. Oh, 4x plus a negative 3x, or minus 3x, that's just x squared. Plus 1x minus 12, or x squared plus x minus 12. That we've done it. We've done it. We multiplied the following binomials. We multiplied them. That's pretty easy. Frank, this is easy.
I know. Let me go to sleep.
Frank, you gotta do the notes.
No, I'm 70 years old.
Oh, go to bed, Frank. So that was the first example. Let's try another one. All right, here it says multiply the binomials x minus 3 and x minus 7. Okay, let's see here. What do we do? Well, that just means, all that means is set it up like we had here with the parentheses. So that's what I'm going to do. Multiply those binomials. I'll put them both in parentheses. X minus 7. And then I'll do first terms, that's x squared. Last terms, no, outside terms. X times negative 7 is negative 7x. First inside I just remember this shape. It kind of looks like a claw. Yeah, so then what's negative 3 times x? I'm doing that part. Negative 3 times x is negative 3x. You know, negative 3 times negative 7, that's positive 21. You know? You know? Yeah. So you get x squared minus 10x plus 21. So that's all you got to do. That's it. That's very simple. It's very, very simple. Any questions? No questions? Great. All right, moving on. Oh, look at this one. This one's fancy. Write a second-degree polynomial that represents the area of the rectangle below. What's the area of a rectangle? What's the area of a rectangle? I don't know. That's a lie. I do know. I do. The area is the length times the width. You know, the length times the width. What's the length then? What's the length of this? Well, that would be x and 3. If this distance is 3 and this distance is x, well then, if I added it together, that would be the whole entire distance, right? So this would actually be x plus 3. X plus 3. Isn't that fantastic? And then what's the width? Well, the width, maybe you can think of it. Maybe pause it and think of it. Write it down. What is the width? It is x plus 1. Isn't that fantastic? Isn't that fascinating? So what do we got to do? It's the length times the width. Well, that's just multiplying those two things together. Be the plus 3 there. And then, it's like a dirt bike. And then you multiply that together. What do you get? Well, you foil it. You make a claw. Well, that's just x squared plus 3 times x, and then oh no, I did it backwards. It doesn't really matter, but just to keep it consistent, that would be x times 1, then the 3x plus the 3x, and then plus 3. So what do we get? X squared. That's plus 4x, because those are like terms. Yeah, and they're the same sign, so we add them. And so we get that. There it is. That's also known as the quadratic. Second-degree polynomials are called quadratics as well. So there's that. I think I'm going to stop this video right now just because I want to do more examples. But I'll show you in the next video because this is already about 8 minutes long. So there you go. Second-degree polynomials are also called the quadratics. Good day, sir or madam.